to have to determine the rate, of course, maybe using a specific procedure which we're going to mention. Now, in this case, we know that the units for measurement of concentration is molarity that we have mentioned, and then the units for measuring time is T, which of course is seconds. Now we're going to indicate the units as such. So for that case, this is meters, molarity per second, where we said that molarity is the number of moles per liter of a solution. So as I have said, if we have a reactant A that is forming a product B, we can demonstrate the rate at which the reactants are being consumed and the product is being formed. Now let's look at this particular example of this is a reactant and this is a product. We have said that we note the concentration for the reactants by the square brackets of A and the products by the square brackets of B. So this is a reactant and this is a product. So in that case, if we have a reactant and a product denoted as such, then we can write their rate of reaction as we said that the reactant is being consumed, so it will be a negative delta square brackets of A all over change in time. Of course, we have given the units as molarity per second. So for the product, then its rate as well will be given as, now there is no negative sign which is implying consumption, but there is a positive one, change in delta, that's delta B over change in time. So in that case, this one is when the reactants are being consumed, there's a negative sign here implying that they are decreasing. Now this is a decrease and this is an increase. The reactants are being consumed where the products are of course being formed. Now we mentioned an aspect of stoichiometry. Sorry for that. When we were giving some specific examples, I mentioned an aspect of stoichiometry, of course, where I gave the lowercase letters for A, B, and C. It's A, B, C, and D for a reaction that we are